All right, welcome back. We are doing Chapter 10, Section 5, Experimental Probability, and Section 6, Theoretical Probability. So an experiment is the actual activity. So when you're finding experimental probability, it's what the experiment gives you. So each trial is each individual experiment that you do. The more trials, the better the outcome. The outcome is the results, and the sample space is all of the possible outcomes that there are. So if you go down here, the first question is rolling a number cube. How many sample spaces are there for a number cube? And that's just a dice. So this dice right here is a number cube. So if you roll that dice, how many possibilities are there? There's a 1, 2, 3, 4, 5, or 6. So the sample space is 6. So when we find our experiment, we're going to divide by 6. Tossing a coin, you're either going to get heads or you're going to get tails. Each time you toss, you can check. So our experiment sample space is 2. It's either heads or tails. And then spinning a spinner, you have 4 different possibilities that you can get. And so we have a sample space of 4 different outcomes. Okay, there we go. Now the dice rolls. All right. More definitions. The event is the set of outcomes. The probability is measured either as a fraction or in the percent. And then these words are important. Impossible means there's no way it's going to happen at all. Unlikely is less than 50%. As likely as not is 50%. Likely means more than likely to occur, more than 50%, and certain means it will definitely occur. All right, so we have a frequency table here, and frequency means the total times it occurred. So we're rolling a 3-colored spinner. So 7 red, 8 blue, 5 green. So the total here is 20. So our total amount of times that we spun was 20. So we got red 7 out of the 20 times. So that's our probability for red. Blue, we got 8 out of the 20 times, and you do need to reduce. Those are both even, so we can make that 4 out of 10. Those are both even, so we can make that 2 out of 5. And you can go straight to 2 out of 5 if you see that you can take a 4 out of those. Green, 5 times out of the total 20, so we can reduce that to 1/5, 4th. There is not a yellow that even exists, so that would be 0 out of 20. And not blue means red or green. So that would be 12 out of 20, which reduces to 3/5. So we are now going to use probability to make a prediction. So if a manufacturer is inspecting 800 light bulbs, so that's our sample space, how many actually inspections happened, and 796 of them did not have defects, then 796 out of 800 is the probability of no defects. Now you can leave that probability in a fraction. That seems kind of like a lot to reduce. So if you put that in your calculator, you'll get 0.995, which is 99.5% that do not have defects. The next question says that if you order 3,000 light bulbs, how many will have no defects? So we're just going to take that 3,000 and multiply it by 99.5%, which is 0.995, and our answer is going to be 2,985 light bulbs that do not have defects, since 99.5 don't. Theoretical probability is not doing the experiment. It's in theory what the probability would be. So it's the different options that can occur divided by the total number of equally likely outcomes. So if we look at our dice again, the theoretical probability of rolling a 3 would be 1 out of 6, because there's 1 3 out of the 6 different possibilities. Rolling a number greater than 3, so that would either be the 4, the 5, or the 6. So that is 3 out of the 6 possibilities, which is 1/2. Rolling an odd number, that would be 1, 3, or 5. So that would be 3 out of 6 again, which is another 1/2. Rolling a 7, that's impossible because the number of dice only goes up to 6. So 0 out of 6 is a probability of 0. If you were asked to find the experimental probability, you would actually do an experiment and then find the probability from your outcomes. The complement of an event is that they'll all add up to 100%. So the event plus the probability of the complement, so that's like everything that didn't occur, it'll always equal 100%, which is 1. So the probability of rolling a 5 on a number cube, a dice, is 1 out of 6 possibilities. The probability of not, this is your complement, so there's 5 of them that are not a 5. So 5 out of 6 is the probability that you will not roll a 5. If you add those two up, you get the 100%, the 6 out of 6. So we know we have all of those accounted for. Now we're going to draw some marbles. So in this lovely jar, our probability of drawing green is 0.2, blue is 0.3, purple is 0.1, and we do not know the probability of white because this problem is explaining that there are 4 different color marbles. So if the total probability of everything is 100%, which it always is, 0.2, 0.3, and 0.1 give us 0.6. So the probability of the last option would have to be 0.4, 40%, because that would allow all of these to add up to 100%, or 1. Odds is a little bit different than probability, but it uses the exact same numbers. So in probability, the denominator is the total. In odds, when you add up the favorable and unfavorable, that's the total. So the odds in favor of rolling a 3 on a number cube. Well, the probability of rolling a 3 is a 1 out of 6 that it's going to occur. So the odds of rolling a 3, 1 3 will be rolled to the 5 not 3s that will be rolled. So this number is actually the complement, and together they add to give you the denominator of the probability. So the odds against would mean that your 5 is going to be the first number because you're not going to roll a 3 5 of the 6 times, and you are going to roll a 3 1 of the 6 times. So we have a bag, 3 blue, 2 red, 5 green. Probability of choosing a red. Probability of choosing a red, that's your fraction, is 2 out of the total, which is 5, 6, 7, 8, 9, 10. We do need to reduce that to 1/5. The odds in favor of choosing a red. So 2 of the 10 marbles are red. 8 of the 10 marbles are not red. That as well needs to be reduced. So it's a 1 to 4 ratio. 1 red to 4 not red. And then the odds against choosing a red is just that flipped. It's a 4 to 1 or 8 to 2, but you do need to reduce. And that is it. I'm going to put not red right here. Red. And I'll put red, not red. You just need to make sure in favor means you're going to get what you want. Against means you're not going to get what you want. So that is a very doable thing. Have a great night.